Section 4.4 is the graphs of sine and cosine, which are called sinusoids. If you look at the shape of the graphs of sine and cosine, they make a wave pattern, and those graphs are called sinusoids. So the equations that we look at when we're looking at these are the graphs of y equals a times sine of the quantity b times x minus h plus k, and y equals a times cosine of b times the quantity x minus h plus k. These are the general forms of the equation where a, b, h, and k are variables. A and b have to be non-zero, and then these two equations have the following characteristics. We can calculate amplitude to be the absolute value of a, where amplitude is half the height of the wave. So amplitude is the height of the wave from the midline. Then we can calculate period to be 2 pi divided by the absolute value of b, and that is the length of one full cycle of the wave. Frequency is the absolute value of b divided by 2 pi. Notice it's the reciprocal of the period, and that's because frequency is the number of times of complete cycles the wave completes in a unit interval. Okay. When compared to the graphs of y equals a times sine of bx and y equals a times cosine of bx, they also have a phase shift, that is a horizontal shift of h, and a vertical shift of k. So that defines what our different variables do in that general equation. Okay, looking at example 1, we want to graph each of the functions by hand without a calculator, identify the maximum and minimum values on the interval from negative 2 pi to 2 pi. So immediately I recognize that 2 pi is a full rotation or a full cycle on the unit circle. So we're looking at 2 full cycles on the unit circle. So if I'm looking for the equation y equals 1/2 of cosine x, I'm going to start by sketching the base graph of cosine. Okay, now because we're working in radians, I'm going to mark on my x-axis in radians. So each quadrantal angle, starting with pi over 2, pi, 3 pi over 2, 2 pi, and then likewise on the negative x-axis, negative 2 pi, negative 3/2 pi, pi, negative, and negative pi over 2. Okay, and I know that cosine has a maximum of 1 and a minimum of -1. Now cosine, remember, is the graph that goes through the maximum on the y-axis and has zeros at our values of pi/2. So it will look something like this. Okay, so again, that is just the graph of y equals cosine of x. Now I want to graph y equals 1/2 times cosine of x. Now that 1/2 is my a value. A equals 1/2. So that tells me that my amplitude has been multiplied by a factor of 1/2. My amplitude is 1/2. That means my maximum and my minimum value change by a factor of 1/2. So my new value for each point that I go through has been adjusted. Like this. Y equals 1/2 times cosine of x. Okay, so for this equation we have a maximum value of y equals 1/2 and a minimum value at y equals -1/2 on the interval from -2 pi to 2 pi. That's the interval that we graphed. For the next two problems, you'll do something similar. Notice here, your a value is negative. Your amplitude should always be positive because it's an absolute value. However, your graph will have to reflect and adjust for that negative. The next page, for example 2, we want to write the cosine function as a phase shift of the sine function and the sine function as a phase shift of the cosine function. Remember, phase shift, which was our horizontal shift, is adjusted by our variable h. So when we're writing cosine of x in terms of sine of x, it would be sine of x plus pi over 2, where our phase shift is pi over 2. For sine of x, it will look very similar, except instead of our phase shift of positive pi over 2, we will write cosine of x with a phase shift of negative pi over 2. This tells us that sine and cosine have exactly the same shape, but are shifted by a phase shift of pi over 2 or negative pi over 2. All right, after reflecting upon the lesson, go ahead and summarize what you learned today from this lesson and write it in this box.